Today we're going to discuss limiting reactants. This is what we talked about in that POGL as we were going through and looking at our cars and what piece of the car limited how many cars we could actually make in the factory. This might be difficult to follow at first, but as long as you can do stoichiometry, which you just took a quiz over, you should be fine. The first step to calculating limiting reactants is to write a balanced equation. For those of us that are still confused on writing equations from words, you need to make sure that you can do that before your test on Tuesday. I will be back this afternoon for tutoring, but I will be in supper club. So if you need to stay for tutoring and need help on this, I will be in supper club. Step 2, for each reactant, calculate the amount of product that we form. It should ask for a specific product, like how much sodium chloride is formed. And then that is the product that you're looking for. You will have to do 2 calculations that are stoichiometry calculations. And step 3 is that the smaller answer indicates how much product we make and what our limiting reactant is. The limiting reactant comes from the product that we make. Remember, we can only make the smaller amount. I do not have enough of our other reactant to make the larger amount. When we are going through our problem, step 1 is to write our balanced equation. So we need to keep in mind our charges and we need to think about crisscrossing them. We need to keep in mind our polyatomics just to write our equation. And then you need to make sure that you can balance it properly. Also, please make sure that you leave room for coefficients in this equation. So when copper 2 chloride is copper Cu Cl2, because the 2 crisscrosses down to be the chlorine's charge, plus sodium nitrate, which is NaNO3. Sodium has a +1 charge and nitrate has a -1 charge, so they cancel out. These make copper 2 nitrate, so CuNO3 plus sodium chloride, NaCl. At this point, you need to make sure that you're ready to balance the equation. So the first thing you should start with are our polyatomics. On the product side, we have 2 nitrates, and on the reactant side, we only have 1. So we need to go ahead and put a 2 in front of sodium nitrate, which then affects our sodium, so we need to come over here to the product side and put that as well. Now below each reactant, and there's a question mark under our sodium chloride. We need to go to grams for sodium chloride for both of these original numbers. So I get 15.0 grams of copper 2 chloride. And we are going to grams of sodium chloride. The mass of NaNO3 is 84.994 grams. And at this point, we can go ahead and get rid of our mass of NaNO3 because I'm done with it. The next step will always be the mole ratio. In my problem, I have 2 moles of sodium nitrate and I have 2 moles of NaCl because we are still looking for NaCl. Again, my moles of sodium nitrate cancel out. If you are not writing the compound, you will probably not do this well. My last step is going to the mass of NaCl, and it is the same mass as we found before. Please do not try to calculate this again, because there's no reason to do extra work when we don't need to. And let's go ahead and get rid of some of this line. Okay, that's not working. When we put this number in our calculator, 20 times 58.443 divided by 84.994, I get 13.7, sorry, it's 13.8 grams NaCl. When I put all this in the calculator, I get 13.0 grams NaCl, which is what I was looking for in the mass of NaCl. Once I have my answer for my first problem, I need to work my second one. It gave me 20.0 grams sodium nitrate. The mass of sodium nitrate is 84.994 grams, and that is always equivalent to 1 mole. Remember to keep in mind that you need to cancel out the units. Those of you that don't cancel out the units, we generally have issues later on. Next step is the mole ratio. I have 2 moles of sodium nitrate, and I have 1 mole, sorry, that's 2 moles of sodium chloride. Again, cancel out our units from top to bottom. We have one more step. My last step is to multiply by the molar mass of sodium chloride. 1 mole of NaCl will go on the bottom, and the mass is 58.443 grams. Which is equal to 13.8 grams of NaCl. So this step is to figure out how much product I can form, and that amount happens to be the 13 grams of NaCl. And I am attempting to highlight it, but it apparently is not going to. So I will just box it in. 13 grams of NaCl. At this point, it's going to ask us what our limiting reactant is. So our limiting reactant is the reactant that our smaller product came from. So our LR, which is our limiting reactant, is CuCl2. Sometimes it will also ask for the excess reactant. That occurs when we've already found our limiting reactant, so the other one must be excess, which means we have extra of it. So we're going to use our final answer that we calculated, which just a minute ago was 13 grams of sodium chloride. And we're going to go back to the original mass of the excess reactant. This is the one that's not limiting. There should only be 2. Once we've done that, you need to subtract how much we used from the original amount it gave us, and then that's how much excess we have left over. So if we are using the same example, we need to start with how much we started with or ended with. That's 13 grams NaCl. And we need to go back to this one. This is our excess reactant. So back to grams. Our excess, or our sodium chloride's mass, is from the periodic table 58.443 grams NaCl, and that's equivalent to 1 mole NaCl. At this point, our units cancel, and we are concerned about mole ratio. I have 2 moles of NaCl, and I have 2 moles of NaNO3. Again, units, moles of NaCl cancel. And then our last step is to multiply the mass from the periodic table. Again, one more time, this is 1 mole at the bottom. NaNO3. And its mass is 84.994 grams. So this is going back and figuring out how much I use if I can only make 13 grams of sodium chloride. In this situation, I use 18.9 grams. The original amount it gave me of sodium nitrate was 20. So I subtract how much I used, 18.9 from 20, and we get 1.1 grams of NaNO3 excess. So in a situation where it asks me how much limiting reactant I have, I need to do 2 problems. If it asks me for excess as well, I need to do 3, but the third one is going backwards, and then you need to subtract. Just remember, Tuesday the 16th, you will have a test on limiting reactants, stoichiometry, and excess reactants. I am only going to see you one more class period. If you have not already brought in your mole project to be weighed, at least the aluminum part, it must be weighed before class on Thursday, and you need to have your calculations. There will not be any time in the middle of class for you to be doing your aluminum foil part of your mole project because you didn't come in and weigh it prior to Thursday in class. You may come Thursday morning, you may come tomorrow morning, you may come tomorrow afternoon. But remember, I'm not going to be here after school.